Hi, Calculus. Let's do some questions from your checkup. 6-2. Okay, so for that first one, we want to solve the differential equation with the given initial condition. So we're going to separate and integrate. So I'm going to, on the right-hand side, just move the y. So I end up getting dy divided by y equals negative 6x dx. There's step 1. Step 2 is going to be to integrate. So this becomes ln of the absolute value of y, and this side is negative 3x squared plus c. Next, I am going to find c using the initial condition x is 0, y is 5. So I've got ln of the absolute value of 5, which is 5, equals negative 3 times 0 squared plus c. So c is ln of 5. All right, so now I'm going to come back to this spot and plug in c. So I've got ln of the absolute value of y equals negative 3x squared plus ln of 5. Let's collect our ln's on the left-hand side. Now I can condense my logs using division. Now I can exponentiate. Let's multiply both sides by 5. And then I can drop my absolute values on the left if I add a plus or minus on the right. And then testing that initial condition, I want 5 equals plus or minus 5e to the 0. So I want the positive branch. So final answer, y equals 5e to the negative 3x squared. All right, 1b. I'm going to multiply both sides by y. So I get y dy equals 3x squared dx. There's step 1, separate. Step 2, integrate. So here I'll have 1/2 y squared, and here I'll have x cubed plus c. Now I'm going to plug in my initial condition, 1 for x, negative 2 for y. So negative 2 squared is 4, half of 4 is 2, and 1 cubed is 1. So if I subtract 1 from both sides, I get that c is 1. So I'm going to plug that back in at this spot. So I've got 1/2 y squared equals x cubed plus 1. I'm going to divide both sides by 1/2 or multiply by 2. And then I'm going to raise both sides to the 1/2 power. But I do need a plus minus when I do that. Then if we check our initial condition, plugging in negative 2 for y and 1 for x, the inside becomes 2 plus 2, which is 4, and 4 to the 1/2 is 2, so I want the negative branch. So final answer, y equals negative quantity 2x cubed plus 2 all to the 1/2 power, or the square root of that quantity. All right, question 2. The average value of a continuous function f of x over the interval 4, 7 is 21, and we want to know the value of that second integral. So let's first take this statement and turn it into an equation. So the average value formula is 1 over b minus a, so 7 minus 4, integral from a to b of f of x dx. So that's the average value, and we know the average value is 21, right? So very conveniently, these are the same bounds for the integral that they ask in the question. Let's isolate the integral by multiplying both sides by 3. All right, so now I've got this piece, but be really careful because it's really tempting to just multiply by 4 and add 3. but notice that that 3 is inside the integral as well. So you have to integrate it. In other words, let's split up our integral. So let's make it 2 integrals. So I've got the integral from 4 to 7. I'm going to bring out the 4, f of x dx, plus the integral from 4 to 7 of 3 dx. Alright, so this first integral I can replace with 63. That second integral I can anti-derive, so 3x, and evaluate that at x equals 7 and 4. So 4 times 63 is going to be 252. Plus here, I can factor out that 3 and then evaluate x at 7 and 4. So I end up getting 252 plus 3 times 3. So 252 plus 9. So final answer, 261. All right, question 4. The rate of change of a population y is proportional to its size. So we know that we can use our y equals c e to the kt, where k is a constant and t is measured in years. If the population doubles every 11 years, then what's the value of k? Okay, well, remember that our k value is equal to ln of 2 over the doubling time. So this is just ln of 2 all over, and our doubling time was 11 years. And you can leave it like that or type it in, but it's really important that we remember these formulas. If we were given the time it takes to triple, you would take ln of 3 divided by that time that it took to triple. If you were given the half-life, you would take ln of a half divided by that time that it took to get to half the amount. All right, question 5, we want to match the equation to the slope field. I'm noticing that this is really standing out to me. So that is when y equals 0, dy dx is 0.
Sandy Bidey.
Hold on, I had a call from Mrs. Bobby. All right, so when I plug in y equals, I don't know why I put 0, y equals 2, then the slope should be 0. So this is not going to work for me. This is, there's nowhere even to place y in there. B works and E works, C does not work, okay? All right, so now we can notice that if I pick y values greater than 2, up here, notice that all your slopes are negative, okay? So that means we need B, because if I pick like 3 for y, then I get a negative dy dx, right? So we can do that. We can say, pick the point like 0, 3. We should get dy dx is negative, and that is the case for B, but not E. Problem 6. So we will always want to start our limits by plugging in this case, n, or 0 for n. So I get sine of 0 plus 0 over sine of 0 plus 0, which is 0 over 0. So do more. So we're going to do L'Hopital's rule. So I'm going to take the limit as n approaches 0, take the derivative of the numerator over the derivative of the denominator. Now make sure you do chain rule. So derivative of the numerator is 2 cosine of 2n, because I have to multiply by the derivative of the inside, plus 1. Similarly here, we've got 3 cosine of 3n plus 1. When I plug in 0, I get 2 times cosine of 0 plus 1 all over 3 times cosine of 0 plus 1. Cosine of 0 is 1. So at final answer, I'm getting 3 over 4. All right, question 7, we're taking the limit as x approaches negative infinity. So again, we've got to be so careful. well, if you're correcting this one, I do want to see the graph of e to the x, so an exponential growth, something like this. Notice that as x approaches negative infinity, your y value for the whole exponential piece approaches 0. So I want you to box or highlight your exponential pieces, and then you're going to replace that exponential piece, not just the x, the whole term, with 0. So final answer, 3/4. Question 8. So if this is our function, then we want to find f, and then in parentheses we have this 4 of x, and that means the fourth derivative. Okay, so the first derivative, we need chain, it'll be 2e to the 2x minus 1. The second derivative will be 2 times 2e to the 2x minus 1, so 4e to the 2x minus 1. The third derivative, multiply again, chain rule, 8. And the fourth derivative will have a coefficient of 16. So final answer. All right, problem 9. If it's helpful, you can rewrite this as the quantity 3x plus 4 to the negative 1. So notice that this is an anti-chain. You've got a function inside another. Your outer function is x to the negative 1. So anti-derive that. Hold the inside. Then step 2, divide by the derivative of the inside, which is 3. So multiply by 1/3 in front. Don't forget your plus c. Question 10. We have f prime, and we are given f of 0.2. We want to find f of pi over 3. So this is FTC rearranged. So your a value is 0.2. Pi is about 3, so 3 divided by 3 is 1, so pi over 3 is greater than 0.2. So pi over 3 is your b. And remember, it goes f of b equals f of a plus the integral from a to b of f prime of x dx. So I want to find f of pi over 3. F of a is 0.9. And then we're going to add the integral from a, which is 0.2, to b, which is pi over 3, of f prime, which is square root of e to the 0.52x sine of 3x. And I'll let you plug that into the calculator. Math 9 that. Make sure you're in radians. All right, question 11. We're going to make the calculator do it for us. We are given the velocity at any time t. We want the acceleration. So a of 5 will be v prime of 5. So just do math 8 for me here, where this is your function and we're evaluating at t equals 5. All right, I'm going to do 12, 13, and 14 kind of all together. So we have this region S. So here's my region. And we're just setting up integrals, okay? So question 12 says find the area, okay? So area, I'm going to go top minus bottom dx. So that means I'm going to be in terms of x. So grab your domain, -2 to 2. The top is f of x. The bottom is g of x. Don't square anything for area, dx. Okay, if you got this wrong, tell me in words what you missed. Like, did you add a square, or what happened? Did you use the range instead of the domain, etc.? Okay. Now, let's see if I can erase just this line. Yep. All right. Now I want to revolve region S about the x-axis. So here's my axis of revolution. Yes, my region touches the axis, but there is empty space, okay? So I need washer method. So start at your axis of revolution, go perpendicular to your farther function, that's capital R. Come back to your axis of revolution, go to your closer function, that's little r, okay? And we're going to go pi integral from -2 to 2 of capital R squared minus little r squared dx. So this becomes capital R is f of x minus 0, and little r is g of x minus 0 dx. Again, if you got this wrong, please put in words what you missed. All right, question 4. Region S is the base of a solid. Find the volume if cross-sections perpendicular to the x-axis are semicircles whose diameter lies in region S. So here would represent one diameter. I want to take an infinite sum of all these diameters, and remember that's pi over 8 diameter squared. I see that's top minus bottom, so still in terms of x. So now I just need a formula for d. Again, that's top minus bottom, so f of x minus g of x, that'll be squared